Okay, welcome back. Section 4.4. We've done multiplication, division, we've done roots and exponents, so it must be time to do addition and subtraction. Those operations that normally come last. This is, of course, for fractions, and we're breaking this up. 4.4 is doing addition and subtraction with common denominators. So that is where we have the same denominators, where our denominators are in sync. In general, right, so a over b kind of plus or minus something that looks like c over b. So the idea is that our denominators are in sync, and so when that happens, if we're going to add and subtract, all we're going to do is add and subtract up in the numerator. So numerator to numerator, the denominator stays consistent, right? So the denominator stays the same. So b to b to b, and we just shift this operation up into my numerator. If we have something to reduce in the end, we'll reduce it. If we don't, then we won't. And it's as simple as that. So let's sort of look at a few examples. Let's say I want to do 7 over 15. I want to add it to 4 over 15. So this is going to go super fast because all that needs to happen, right, is we're going to say, well, 15 and 15 are in sync. So my denominator is 15, and I'm just going to do this addition up top. So then 7 plus 4 shifts to the top. 7 and 4 is 11, all over 15. That's not going to reduce, so we're done. Just like that. Extremely fast, right? So the idea here conceptually is that your fractions, right, the sort of amount that you have is your numerator up top, and the type of fraction you're working with, right, the type of fraction that this is the value on the bottom, denominator, right? So this is sort of 7 and 4 fifteenths. So if the type of thing is in sync, all we need to do to sort of add or subtract is just add and subtract however many we have, and the type stays the type. Let's say we did some subtraction, right? How about, I don't know, 11 over 18, let's do minus something like 4 over 18. Pretty simple, right? The idea is 18 and 18 are in sync. So I get my 18 on the bottom, do this subtraction up top, right? 11 minus 4, that's going to get me a 7 over 18. That's not going to reduce at all, right? I'm still just going to have 7 over 18, and that would be that. To see, doing these examples a little bit off the top of my head, I was kind of semi-hoping and expecting some of these to reduce, to have a little bit more steps. Let's throw in some variables. So we can do a mixture of things. We can do sort of variables in the denominator. So we could do something like 9 over 10x squared, right, minus, I don't know, 3 over 10x squared, right? So the denominator here is a little bit busier, 10 times x squared, but that doesn't particularly matter because what's important here is that they match and they're in sync, right? So this is going to be 10x squared for us on the bottom, and then we're just going to do 9 minus 3 up top. So this is going to look like 6 over 10x squared. And finally, we have something that will reduce down a little bit, right? So 6 and 10 are both even numbers. So this would be 2 times 3. This would be 2 times 5. So we could reduce these 2's out of here. So this is going to be 3 over 5x squared. And that's going to be our final. So you might not necessarily end up, once it's reduced with your final answer, having the same denominator that you started with. That can happen. Those things can change, and that's totally fine. That is not unreasonable. Let's do one more variable guy. What if we throw some variables up top? Let's do something like, I don't know, 5x over 24y. Let's do plus something like 7 over 24y. So if I start to change these variables up a little bit. One of the things here that's happening is I've got denominators that are in sync. The whole idea with this section is that our denominators will be in sync, so we won't have to think too hard about that. But then up in my numerator, what's going on? So this is 5x plus 7. So if we start to throw variables around a little bit, in theory, right, one thing that can happen is we could end up with values that are not like terms, right? So 5x and 7, I mean, in theory, we're trying to sort of add them together. But these are not like terms, so they won't add together, right? 5x and 7. You're going to kind of want to do 5 and 7 as 12, but 5 has an x and 7 doesn't. So this is not going to add together. That also definitely limits us a little bit more in terms of trying to reduce this down, right? If I'm going to reduce something to lowest terms, if I'm talking about a fraction that looks like this, I have to just kind of leave it with this addition up top, and then I can only reduce something out of this fraction if it comes out of the bottom and it comes out of both of the terms up top. So for example, right, 5 and 7, in this case, neither of those really has anything in common with 24 to begin with, so it's kind of moot. But in theory, before you could reduce anything down, you would need to have values that you're pulling out of everything on top and then sort of also out of the bottom. That's the basics of it. So when we have a common denominator, all we do is add or subtract everything up top. The denominator on the bottom stays the same, and that's going to be the form.